Hey everyone, can you guys hear us? We're doing a sound check real quick. Awesome, thanks. So this is our introduction to Sandbox, Evasion, and AMSI bypasses class that we taught at DEF CON last year. The slides, we pushed a few, we've made a few changes to them, but for the most part, they're going to stay the same. Some of the obfuscation stuff that we taught is working questionably right now because Microsoft pushed a fairly large update to AMSI and Defender last weekend that we haven't quite figured out all of the nuances to it yet, but we should be able to work through that. I've got all of the sample scripts we're going to have you guys work on obfuscated myself so that they do work, but it might take a little more work than normal. So we'll go ahead to the next slide. This is just a legal disclaimer that we've thrown in here that, this is informational purposes. Don't use it for bad things. So we'll go ahead and do introductions. I'm Jake Krasnov. I also go by Hubble. I'm the CEO for BC Security. My background is I was in the Air Force and did cybersecurity testing for aircraft, for fighter jets specifically, and then went to the Air Force Red Team for a year and a half. And now I'm focused on embedded system security stuff, and I'll let Coin and Vinibot introduce themselves as well.
Can you hear me?
Yeah, I can hear you.
Okay. So I'm Vince, CTO, BC Security. I built the Starkiller UI that we recently released for Empire, and I do a lot of the dev work on our fork of Empire as well.
Okay, and it sounds like I'm being told that Coin is having audio issues. So Coin is our COO. He's got quite a varied history. He's presented at DEF CON a few times, and he focuses mainly on Bluetooth and wireless security stuff for us. And then we'll go ahead and move on. He's running all the moderation for us, so all the polls and answers from BC Security you see in the chat will be Coin. So why are we here? Is one of the main things we're going to be going over is how to mask your malware. A big focus of the course is going to be code obfuscation because it's the primary means that we use to bypass lots of these security measures. And it just gives us a really good understanding of what it is that's getting us caught when we understand how to obfuscate properly. And we'll show a few examples of why that matters. So here's just a quick overview of what we're going to cover in the class so far. We'll go over AMSI and what it is and how it works. We'll give you some examples of how the malware is triggered by triggers AMSI and what those responses look like, as well as the how to pull like Defender logs and stuff and see exactly what it is that is triggering, whether it's AMSI or real-time protection or some other part of Defender. We'll go over obfuscation techniques. We're going to go over using invoke obfuscation mostly because it's got a ton of useful features in it that's built into Empire, which we'll show you guys how to use, but it's not intuitive to use it inside Empire. Unfortunately, we're working on fixing that. We'll go over 2 different AMSI bypasses that are still pretty effective, then go over some sandbox evasion, then we'll have you guys put it all together. Yeah, so like I said, goals is for everyone to understand what AMSI is and why it's important and how it's kind of really changed the landscape for a lot of modern red team engagements. Learn to analyze your malware scripts before and after execution and what it is that's actually triggering it to help you kind of narrow down, because super heavily obfuscated scripts can actually be an indicator of compromise in and of themselves. So minimal obfuscation is actually more ideal than just heavy obfuscation. We're we're going to try and understand how to obfuscate code to avoid AMSI and Windows Defender, and then detect and avoid sandbox environments for either to try and prevent like blue team analysis or to get past a lot of email services and stuff that are now using behavioral analysis inside of sandboxes to identify malware attachments instead of just scanning the code statically. So we will teach you how to operate Empire, obfuscate PowerShell, and avoid AMSI and sandboxes, but we're not going to really teach anything beyond that. We're not going to get into the post-exploitation aspect of things and pivots and that kind of stuff. So I will just pause real quick and see if anyone's got any questions right off the bat on on expectations or anything like that. Give Coin a chance to try and fix his audio real quick because he's still not able to talk. But so we'll just take a minute here. Cool. Okay, so what is AMSI? I'm going to read you guys the Microsoft official definition for what AMSI is, which is the Windows Anti-Malware Scan Interface is a versatile interface standard that allows your applications and services to integrate with any anti-malware product that's present on a machine. AMSI provides enhanced malware protection for your end users and their data, applications, and workload, which that's all great and everything, but what does that really mean? The big takeaway for AMSI is that it evaluates commands at runtime when they go into the scripting engine. It applies to VBA, JavaScript, PowerShell, and it does work on VBA Office macros, but that's still being worked on. It's not as effective as it could be. It's not as effective as it is in just the PowerShell, JavaScript, and VBA runtime engines themselves. The other thing is that AMSI is antivirus agnostic. It offers an API that can be utilized by any antivirus product on the market. We're seeing more integration with AMSI for like McAfee and Kaspersky and that kind of thing, but Defender is definitely the one that leverages it to the most effect. And then the reason that it was developed was to identify quote-unquote fileless threats, which are they're not truly fileless because there has to be some kind of either like malicious Office document or a malicious download .exe or DLL or something that's executed. But it's really just what we call a download cradle that pulls down the rest of the malware and is just a really minimal piece of code. So 90% of the malware runs strictly in memory and never hits the disk. And so AMSI was developed to fight that by trying to avoid read code at runtime when most of the obfuscation has been removed. So this just kind of shows a quick overview, like technical look at how AMSI data flows. It's not super important for what we're going to be doing, but it's just kind of a nice image to see how it works and how the information gets passed from applications into the various API layers and then over to the Windows Defender service for action. So one point of clarification for PowerShell, and this really gets to the heart of why we're still able to obfuscate a lot of code, is that even though the code is being evaluated at runtime when things like base64 encoding, XOR encoding, or those other types of obfuscation have been removed, it just evaluates the code when it's readable by the script. So this first command up top says, PowerShell TAC encoded command is a base64 encoded command. When AMSI evaluates it, it evaluates it as that right host test. Like it completely removes the encoding because the PowerShell scripting engine can't process that base64 encoded string. Whereas the third sample down where it says right host and it has TE plus ST is readable by scripting engine. So it doesn't get turned into that right host test. So it looks different than than just the standard right host test, because the scripting engine can interpret it that fully. So it's not removed by AMSI. So that, like I said, that concatenation type of stuff is what really allows us to continue to be able to obfuscate our code around a lot of the signatures that AMSI is using. So now we're going to go into some malware triggering. Or well, I guess we'll see. Does anyone have any questions so far?
Hey Hubble, I'm testing my mic out real quick. Is it working?
Yeah, I can hear you now.
Perfect.
Okay, cool. So the the advantages of using AMSI for antivirus are without the hook into AMSI, most of the antiviruses can't see the code as it's being processed by the scripting engine. So they just see that like base64 encoded string or whatever, which makes it really hard. It basically makes it impossible to build signatures against the malware. Matt Brown, yeah, there is a CLR component, or sorry, CRL component of AMSI now that can look for those types of calls and stuff. We'll get into exactly how AMSI works, because it's not just a straight line specific calls or banned or whatever. AMSI actually builds a risk profile against the script that's being ran and uses that to make decisions, and we'll cover that later. So we're going to move into what it looks like when malware is triggering inside of Defender. So there's a whole bunch of Windows mitigations for anti-malware stuff, of like data execution prevention and arbitrary code guard. There's a lot of stuff built in nowadays. Like Windows has really stepped up its security game, and it is, even just out of the box, is much more secure than it used to be, and fairly secure nowadays. But we're just going to focus specifically on Windows Defender and AMSI for now. So here's just a kind of a quick humorous example that Coin can talk to, since his mic's working right now, from when we were getting ready for DEF CON last year.
So yeah, this was actually a really interesting thing that we came across. We were getting our slides ready for DEF CON, and we went in to load up some of the scripts just to show everybody what they look like, even just in the notes section. And AMSI and Defender flagged the PowerPoint, even with just the text in there, nothing that was executable, as malware. And it showed that all of our AMSI bypasses were being tripped as AMSI tamper logs. So just really shows that they really dig into each of these programs and look for anything that might be malicious. That's all I got, Hubble.
Okay, yeah. So this is how you can pull the Windows Defender logs. Is this get win event Microsoft Windows Defender operational? It dumps all of the current events from the Windows Defender logs. This where object ID equals 1116 is specifically looking for a malware flag. What's interesting to look at on these logs when you're trying to figure out where your malware got picked up, or your payload got picked up rather, is you'll get detection source down here, and real-time protection is not the same as AMSI. That's a different service being ran by Defender that's actively scanning for like files on a hard disk and that kind of stuff. So like that, a lot of times if you're working on something like a malicious macro and you haven't finished obfuscating it, like the autosave will actually get flagged by Defender as being malicious while your file that you're still working on hasn't been flagged, and that's real-time protection is producing that. Whereas if you dump it and it was AMSI that specifically flagged, you'll see in this detection source that AMSI is the thing that picked it up. There's actually, we don't go over it in this, but there's a project called PS AMSI that I believe, trying to remember off the top of my head, I think it's Matt Graber. I can't remember if it's Matt Graber or Cobber that built it. I think it's Matt Graber. That can actually dump more specifically what AMSI is flagging on, like the actual chunk of code that's causing the flag. It's a really useful project, but it's kind of difficult to get set up because of how it interacts with AMSI and Defender and stuff. Yep, Cobber. Okay, cool. Thanks, guys. I couldn't remember off the top of my head. So yeah, in chat, there's someone dropped a link to it. It looks like Ryan was the one that did it. Thanks for the correction. So now if you guys downloaded the code samples, you can open them up and just run them just to see what they look like. And like when you flagged as malicious or whatever. Coin, if you go ahead and switch over my screen to share with them, I'll just show them what it looks like real quick. So yeah, the first sample is like a really simple, just AMSI context is my like go-to trigger test. Like I just know that string specifically will cause a flag. So if we try to run it, yeah, we get this, the script contains malicious content and has been blocked by your. They were in the, if you cloned our slides down from our GitHub, if you cloned our project from our GitHub for the workshop, they were contained there. Coin, can you drop a link for that in the chat for everyone? So then the second sample that is in there is an AMSI bypass that'll be flagged by default when you try and run it. Here, let me try. Is that better, guys? Yeah. So this one is an AMSI bypass that we'll discuss later on. That gets flagged when you just try to run it by default. As you see, it just says the content has been blocked. And then the third sample is a default payload from Empire 2.5 from before we forked it. And it will get caught, but even this, we can still obfuscate enough to get past AMSI. Takes quite a bit of work nowadays to get that done, but it can still be done. So and then just one last time, it'll be flagged. Okay, Coin, if you could just go ahead and switch us back. Cool. So now we're going to go into kind of how we're going to build out our payloads and that kind of stuff, and just a quick overview of the process of what you want to do while you're building your payloads. So first things first is get a working code base of whether you're using Empire, Metasploit, or whatever. Just make sure, like disable all the antivirus on your test range and everything. Just make sure everything's working. Which that seems like a pretty straightforward thing, but you'd be surprised how many times I or other people I've worked with have spent, a couple hours trying to obfuscate some code away till I realized that it wasn't that our code was getting caught, it was that the code doesn't work in the first place. So always make sure that you have your just default payload working and functioning before you start adding in all of your obfuscation and changes and that kind of stuff. Then customize your functions. There's a lot of stuff, especially in PowerShell, since you have access to the .NET assemblies, have more than one way of implementing your functions and your calls, and simply just using some of those varied ways of calling the functions can help get your code past AMSI and Defender and that kind of stuff. Then you'll move into obfuscating your code, and then once you've got your obfuscated code running correctly, it with all of your AV and stuff turned off. Then you'll test it against AV to make sure that it's actually getting past everything that you want it to. So for now, anyone that's following along, we're going to go ahead and disable Windows Defender. So to do this, Coin, if you could flip over my my screen again. Yeah, so one of the new functions that's that was added by Defender, which is not the most recent one, but in order to be able to turn off Defender with this code completely, you need to go into virus and threat protection settings. Manage settings here, hold on. Should help a little bit with the, and then you need to go turn off the tamper protection. It won't let you turn off tamper protection, turn off Defender with that PowerShell command without turning off tamper protection first. And then you need to run PowerShell as an admin to be able to disable it. So. Let's see, yep, there we go. Igor, I'm not. We have not specifically tried to do that because we don't typically seek to do that kind of stuff during engagements because we don't want. We do our best to only use like obfuscation and temporary changes to the clients' computers and stuff. We try as much as possible to make it so that if you like just restart a computer, like a client restarts their computers, that everything goes back to normal because we don't want to leave them in a worse state than we found them. Yeah, it would also require a UX bypass. But so we don't typically use this during engagements. This is mostly just for when we're testing new payloads and want to disable Defender and that kind of stuff completely for running stuff in our labs. Yeah, sorry guys, we know that the bandwidth is kind of getting a little hard here. So that just turns it off, and then we'll go ahead and restart it. Except crap. Apparently there's an update, so hopefully that doesn't take too long. But okay, Coin, if you could go ahead and switch back. When my computer finishes restarting, Ray, I will paste it for you. Or Coin, do you have the command to paste into the window? So we'll go ahead and thank you, Jesse. So we'll go ahead and go over a quick Empire tutorial for you guys. So yeah, Empire, for anyone that doesn't know, is a post-exploitation framework primarily built around PowerShell. It does have Python stuff enabled. Hold on 1 second, guys. I lost a cord for my headphones. They're about to die. There we go. Sorry about that. So right after our fork, it now runs on Python 3.6 and 7. It was one of the major updates we made. It has an encrypted C2 channel, a bunch of adaptable modules. The original project was released in 2015, and then we forked it in 2019 when the original team stopped supporting it. So why go after PowerShell? it's got full .NET access. It's got direct access to the Win32 API layer. It operates in memory, and it's installed by default on Windows. And then it's typically left enabled by admins even today because it's just super useful for remote administration and stuff like that. A lot of red teams and stuff have moved away from it because of things like AMSI and strip block logging and that kind of stuff. And Ray, we have not tested it against PowerShell core yet because a lot of this was written with Windows PowerShell, and I do know that at least in recent up until the core 7 release, that there were some differences that prevented things like, I believe, like Mimikatz and stuff from running completely natively with the way it's implemented now. So we're gonna have to go through and test all the modules. That is like on our roadmap that we want to get to, is that this will all run in PowerShell core so that it's agnostic to where it's being to which operating system it's being ran in, and just only cares about PowerShell. But going back to the C# thing, like, so a lot of red teams have moved away from it because they think it's kind of played out or whatever. That's where this image for the tweet came from. Is we really think that PowerShell is not dead because it's still one of the primary means that malicious actors and APTs are using to spread malware and infect systems. Even though red teams have started moving away from it. So this is just a quick overview of how Empire is deployed. It's got 3 different stages. You've got your stage 0, which is the launcher, which is the part that we're going to be working on obfuscating today. When that successfully runs, it reaches back to the server because it's much easier to generate a connection back to your C2 server than try and have your C2 server reach into a network. Then the C2 server responds with a stage 1 that does all of your key negotiation, and then finally you load up the actual Empire agent that enables all of your command and control functionality. So if you haven't installed Empire yet, you can download it from our GitHub and run the setup.install. If you're running Kali 2020, everything needs to be run with the sudo command now. If you are in Kali and don't want to use the GitHub, you can actually just do a apt install. We are supported by the Kali project, and they pull our project into their repos, so you can just use apt to install the managed code as well. And then you can run it, and we'll go ahead and get ready. So now we'll walk through. This is the splash page that it'll look like. Coin, can you set us up with the side-by-side so they can see the slides too? Cool, and then oh, sorry, apparently I can't zoom while I'm in Empire, so I need to. Yeah, so I have some old stale agents and stuff up from when I was doing some testing last night. But the main thing is if you do like listeners, it'll Cool, it looks like the side-by-side is not working. Oh, it works for some people. I guess we'll keep moving then. Yeah, so if you list out listeners, that'll give you everything that's running. Use listener is how you enable. It's got tab completion, which is nice. And then So what we're gonna do for today, if you're following along on your computer at home, is we're gonna use an HTTP listener. If you type info, it gives you all the parameters that you can set inside of Empire. The only thing that has to be set manually nowadays is the port number that you're using. And so I already have one running on port 80, so I'm just going to set to port 88 for this example. Oh, whoops. It is capitalization enforced, so when I had capitalized set, it didn't work there. So once you have your port set, you can just type execute, and it'll start running a Flask server. And then we're going to go ahead and use a stager. Let's see. Use stager, and then multi-launcher is the one we're going to be testing today. This one's not super useful for engagements, but it's what we use primarily for testing the actual code snippets that are used by Empire, because you're just going to cut and paste it into your VM, but it just gives you a lot of control and makes it easy to see what code you're launching and that kind of stuff. So we can then set our listener to HTTP. When I'm testing stuff by default, oh, I forgot to switch branches. So I am on the branch that we have, the version of Empire that we have not pushed, that we'll push after this class. We purposely had everyone download. The current version of 3.1.3 without pushing the new version, because the new Defender signatures catch it, and we wanted everyone to have one that they were going to have to obfuscate themselves. So when we're testing stuff, I like to start off with setting base64 as false. I forgot capitalization. Yeah, sorry for the issues, guys. We're doing our best. So now when you generate, it'll generate the code without anything going on. And actually, this one will be caught right now, or well, it won't be, because we have Defender disabled. So if we go over to our Windows box, now that our updates are done, yep. And so if you now that this restarted, if you go look at the Defender after you ran that command, once it loads, when you click on your virus and threat protection, it'll say that if you successfully disabled it, it'll say that it's managed by your organization, so you won't even have any options to be able to manage.
I think we just lost Hubble. His mic went out. Can everybody still hear me? All right, let me see if I can get him back on.
Can you guys hear me again?
Yep. Hubble looks like it's back up.
Sorry. Oh man, I was talking through all of that and you guys couldn't hear me. Okay, well, Coin, can you go ahead and switch back to the slides then? We'll walk through what I did. So yeah, so this is just kind of good. These are just some quick slides that are included in the slide deck of the all the options that you can run through. And then setting up your listener, like we saw on the command line. Coin, did you talk through what I was doing when we lost me?
No, I was panicking instead. So.
Oh, okay. Okay, so well, we're going to walk through it a couple other times, so we'll just go ahead and keep moving on. But yeah, you'll set up your listener. All this stuff is editable, but is set up by default now. And you can kind of just have to set your port and then execute to generate it. The multi-launcher, as I don't know if I cut out where I cut out, the multi-launcher is not super useful for engagements, but it is useful for testing the code that you're obfuscating, because the multi-launcher code is what is embedded into all the other modules. So it's just useful for testing things out when you're trying to figure out what is being caught and all that kind of stuff. So we got a successful callback, and then so now we can go ahead and turn Defender back on, which will be interesting since we just had an update, and hopefully we didn't get a major Defender update like we did last weekend around this time. This one, there we go. So I'm gonna kill my listener. Sometimes turning it, by the way, sometimes turning it back on is a little finicky. Sometimes you have to restart twice instead of just once, but normally it works on the first time. Oh, did I die again?
Nope, you're still good.
Okay. Run as administrator. So I'm just I'm re-enabling Defender on my machine is what we're doing right now. So just as we're doing this humorous thing that happened during our workshop last year, actually, Coin, you want to tell everyone about that?
Sure. While you're getting all that taken care of. So last year for DEF CON 27, we taught this workshop. We had everything ready to go. We were testing everything and had no problems. And then we went to the workshop and we started running our disable scripts and our enable scripts. And no matter what we did, AMSI would not catch anything at all. So all PowerShell, all Mimicat modules, everything that was sent through was not getting caught. Turns out a day or two prior to our workshop, Windows released a patch that broke some of the AMSI stuff in the background. So for a good 2 weeks, you could run Empire and Mimikatz and nothing would get caught. So it really derailed our workshop because nothing was getting caught, which kind of was the whole purpose of the workshop in the first place. So just a really interesting little thing that happened.
Igor, I haven't used the. Okay, it looks like it is equivalent. I haven't used it in a while, but I seem to remember that last time I tried using the disable real-time monitoring method, it didn't fully disable everything. That there was still some services being ran by Defender in the background. So it disabled most things, but there were still a few services that were running in the background that would occasionally kill things, and we couldn't really track it well. So that's why we used the new item property instead, because we know that it fully disables it completely. Okay, so now that we're restarted, if we go back to PowerShell, and I zoom in, so now that launcher that worked last time should be caught by Defender. Oh, or maybe not. Interesting. Okay, well, hopefully it's not the same as last time. Or, well, actually, let's double check. Let's just check that it actually enabled. Nope, so yeah, so like my computer didn't, oh, that's right, you have to turn it on manually. Let's see. Oh man, we're not having a repeat of DEF CON, are we? Ah, real-time protection was turned off still. Okay, there we go. Okay, I'm gonna have to restart this a second time. This happened to us last time. Yeah, so you might have to restart twice to be able to turn stuff back on. Okay, so now that I'm restarted, let's make sure that we have real-time monitoring enabled again. Sorry for the technical guys. Nicholas, you can use, see, what you have to do is you'll have to use edit. Like this. Name of listener, host, and then IP. I'm dropping the command for you, like in the chat for Nicholas. Yeah, so that, and then you'll have to disable the listener, and then do enable, and it'll start working again for you. There we go. Well, that's interesting. My computer will not let me re-enable real-time protection. That's a new one for me. Okay. Well, I guess I will have to run on my bare metal, and we can just demonstrate it that way because I still have everything and I still have Defender enabled on my bare metal. So we'll do it that way as a workaround. So we'll take our payload. Oh, not what I wanted. Screen. And so now this should be caught. Yep, there we go. So that time we were successfully caught. Hold on 1 second, guys. Okay, cool. Okay. Yeah. So now it's working on, at least works on my bare metal. So we will keep moving on. Coin, if you could switch me back to the slides, thank you. Yeah. So if you were able to re-enable Defender, it should start flagging on your stuff, and it should no longer work. So this is just kind of walking through making the payload again. If you need it, you don't want obfuscation set to true. And then just execute, you'll get your payload, you can copy it over. If you want, on the encoded one, there's a TAC-W1 that is included in the default payload. That's what causes the window to close when you execute it. If you remove that from your launcher, the window will stay open so you can see if it's being flagged or not. So now, if you haven't tested it, go ahead and test it, and we'll go ahead and pause here for some questions if anyone has any. Yeah, Joseph, you can if you just type kill all in the from the agents menu in Empire, it'll send a command to kill all the agents that are in your database, and then if they're red and stale, you can just do remove all. Okay. Yeah, so the default payload that you guys have should have been caught by Defender, and so which will get us into our obfuscation techniques. So the first one that you'll see that's enabled by default in Empire and often used with PowerShell scripts is randomized capitalization. PowerShell actually ignores capitalization, so it doesn't really matter, with the exception of when you're using .NET assemblies, then it can matter. It's just kind of dependent. But it doesn't matter to the scripting engine for the most part what capitalization you use. But that also means that AMSI ignores capitalization as well, so it's not super effective for evading AMSI or Defender, but it does change like the hash of your just static code, so it's a best practice to enable randomized capitalization inside of your script. So concatenation is probably still one of the most useful and easiest ones that we use. Just simply breaking things up into pieces will cause them to not necessarily be flagged by AMSI anymore or Defender. Coin, could you just flip us back over to? Yep, thank you. And by the way, just more on this, how we don't like this webinar service. For some reason, only one person can control which screens are being shown to you guys, so I have to ask Coin to do it for me. So if we type in var equals AMSI context, this will get flagged, but provided that update that just got pushed doesn't do anything, we can then just break it up like this. and we have no flag, and now the AMSI, the full AMSI context is contained inside of our var variable. So it gets printed out to screen. Interestingly enough, just for people to be aware of, Microsoft just pushed a new update. It used to be that once you had a string inside of a variable in memory, that when you ran like IEX on the string or on your variable, that it would execute without being flagged. And as of last weekend, they now can see inside IEX in memory and flag it as malicious when you attempt to do that. So it makes that is a pretty significant change to the way that we used to be able to do evasion. And then if we'll go back to the slides now, Coin. Luna, it's kind of, but they do it heuristically and statically. They do it based on keywords. It actually looks for script block structures as well. It'll look for specific order of commands being ran or certain if statements being ran in conjunction with other types of behavior. But yeah, it's they can't build signatures for everything. So when you do like concatenation and stuff like that, since that's readable by the scripting engine, it's not reduced anymore before AMSI can see it. It doesn't put all the concatenation together because that's done by the scripting engine. And then PV, the Windows dumping memory is I've seen it happen in specific circumstances. For instance, if you use an encoded PowerShell command as admin and launch like launch one of the Empire payloads, it'll even when you disable AMSI successfully, if you have like invoke Empire, invoke Mimikatz or something as a string in memory, it'll see it in the process and kill it. But it seems to only do that when certain levels of suspicion are reached. During it's because AMSI context is one of the fields that gets modified for some of the AMSI bypasses. So it's called in some of the .NET bypasses to disable AMSI. Yeah. So the next obfuscation technique that we use a lot is variable insertion. So we put part of it into so Enoch, it looks like your defender is still disabled then. Because it's not getting caught, and so it's trying to run it as a command. So it looks like defender is still disabled. So variable insertion is the next one. So again, we can just kind of it's very similar to concatenation, but just another means of doing it to change things up, so that you don't have just one consistent signature that can be seen. And this works because so one. So this works because PowerShell sees the $sign as a sees it as a special character, and it knows that that is an indicator for a variable. So when it sees the $sign, it looks for a variable being used. So then it goes and finds it, inserts it in memory. Sorry, Coin was sending me some messages on the back end, and I couldn't see. I got distracted. So variable. So it looks for the variable and inserts it into the total context, and so that creates AMSI or variable 2 being just the AMSI context. One thing: if you use single quotes, single quotes will actually prevent that from working. So if you want to do variable insertion, you have to use double quotes. Single quotes is how PowerShell indicates to ignore special characters. So another one is format string. This one's really similar to that variable insertion. It's just yet another way of doing it. So if you use the curly brackets with numbers, it'll go and then do attack F at the end. The corresponding positions is where those words will go. And then it'll just insert it in. It's very similar to the variable insertion. Okay, so like I said, the code structure also matters, like the order that certain commands are running and stuff like that. AMSI will flag on. And then so that's like another important thing, especially in some of the newer signatures that we got. We're gonna give you guys like 5-10 minutes. So I'll take questions right now to try and obfuscate the samples that we gave you yourselves to get them to run. Because of the updates on the signatures that were pushed last week, these samples are a lot harder to obfuscate than when we had it as a class. So you guys might not be able to get it all the way, but I will walk through it in a few minutes. I'll share my screen and walk through the various things that you can do to get it to start working. So yeah, just go ahead and start trying on yourselves if you're following along, and then we'll take questions. Coin or Vinny-Bod, do you guys have any input right now?
No, nothing right now. I know somebody mentioned the IEX stuff, so if we're going to do that later, otherwise maybe want to go over that now.
Yeah, so I haven't tried using the set alias yet. Oh, yep, we can go back one slide. But yeah, IEX is now is now evaluated. That string's evaluated in memory now, where it used to not be. It used to be like as long as you could get the variable inserted, it would stop. It would stop being scanned for a second time, and we'll talk about that a little more as to my guess as to why that works. So a lot of this is, especially when we get into more of how the AMSI stuff actually works, there's not any provided documentation out for exactly how it works, for obvious reasons of like they don't want to make it easier for us to figure out how to get past this kind of stuff, or well, not us specifically, but malicious actors. And so a lot of it's our understanding of how AMSI is working, so it's subject to being incorrect if anyone knows a better way. But we'll go over more on the actual way that AMSI is evaluating these scripts and deciding whether or not something's malicious in a second. Were there any other slides that people want us to go back to? Yeah. That's something we plan on looking into, Lona. We haven't Well, so when you say loading PowerShell DLLs into memory, do you mean like the system.automation DLL itself, or do you mean like a modified unsigned DLL? Because the system automation DLL actually contains the hooks for AMSI, so even if you host it in another process, AMSI still hooks into it. Yeah, so the the DLL that's responsible for running the PowerShell engine has AMSI hooks in it. Yeah, Lonut, the actual PowerShell DLL is system.automation.dll. I think I spelled that right. Okay, so Coin, if you want to go ahead and flip over my screen. Yep, thank you. Well, this is going to be, let's see if I can re-enable my Defender now. Maybe it figured, oh, nope, that's fun. Okay, so I will just run it on my bare metal again. So sample one is like really straightforward. It's kind of just the examples we were going over for all of the various techniques of just a standard write host AMSI context. If we run it, it gets flagged as malicious, and then just a simple concatenation will get us able to run this. Although for write host, you do have to use parentheses around it to make it work properly if you don't put it into a variable. And so we got that successfully working. So that's the easy one. And then the next sample is where it starts getting more complicated, significantly more complicated. This used to be a fairly easy example, but the updates in the past week made it significantly harder. So it's actually being flagged now. I was talking about the structure of the code as part of what's being flagged. Close this. So it used to be that, oh, I didn't, doesn't look like I got all of it. 1 second. So one thing that's useful when you're doing this stuff is to try and break your code up into components and run individual steps of your code. Yeah, individual steps of your code that allow you to isolate what part is being captured or being flagged when you don't know exactly what it is. So in this example specifically, it used to be that the only thing that got flagged was this virtual protect section right here. If you just change this virtual protect variable, and it was specifically this virtual protect variable in conjunction with the Win32 functions, was the only thing that you had to change in order to be able to bypass it. But now it's Coin or Vince, you just had your mic come on.
Yeah, I had to fix my headset, sorry.
Okay. Ray, I'll drop the command for you in there. just accidentally hit. So 1 sec, guys. Yeah. So that should work, Ray. Yeah, so the one Jesse dropped in there for the execution policy will also work, but if you do scope current user, then you don't necessarily have to run it as admin. Sometimes the execution policy, if you don't specify scope to current user, won't let you run it without being admin. So yeah, so going back to obfuscating this, so that used to be all you had to do to bypass it. But as of today, when I was testing it this morning, that is, oh, it did work that time. Interesting. When I was testing it earlier this morning, just changing that one thing did not work. So yeah, so on this one, all you had to change was the was this virtual protect variable to get it running. Well, that's good to know. So now when you do that, you'll have to close out your ISE session, because when it only runs in one context. So now AMSI is disabled for this PowerShell context, and you have to restart it. So just close out ISE and restart it. No, I do not want to save changes. So now the final sample is pretty tricky to get past Defender, and then there's also there's multiple things that you have to get past. As of last weekend, there's a new AMSI stream that, if you're not fully obfuscated, will cause it to oh, it does still get flagged for you, Peter. Yeah, I don't know, that's weird. Sometimes yeah, so I can show you guys real quick just the sample that when I had it getting flagged this morning when I was testing it. It looks like some of you are getting. My bare metal hasn't updated its signatures today, whereas this one just updated. I'll show you what we had to change, because this one, it's quite a bit with the new signatures. So I had to go in. I changed the function names just to like get DT instead of get delegate type, and get PA instead of proc address. Dang it.
Can everybody hear me still? I can still hear Hubble, so I just want to make sure it still works for you guys.
Okay, so you guys can still hear me?
Yep, I think it just Nora's having an issue. So
Okay.
try restarting Nora. That usually fixes it.
So that was one thing. That was the first thing I did, was change my function names, because that is something that can help. 1 second, guys. But that wasn't enough to get it passed. That still got it caught. So I also had to go in and I reordered them. So I put, since the function order doesn't matter because they're both being loaded and then called for use down in this section, I reordered them just to change the order of the code, because the order matters for some of the stuff that's being called. And then the last thing I had to do was, where was it? Unsafe native methods is another thing that gets flagged sometimes. So I went and changed the unsafe native methods variable name to just UN anywhere that it was used as a variable, and those things were able to get it so that it finally ran again. Nicholas, you have to make sure that anywhere that get proc address is called is changed to get PA. Joseph, it's called PS AMSI is the one I use. Yeah. Yeah, so so if you have updated signatures, there's quite a bit that has to be done in this script now to get it obfuscated past. You guys may or may not be seeing a secondary flag from Defender. That's a new thing of when you do this kind of stuff, sometimes a new thing we've been seeing this week that I haven't had enough time to investigate to figure out exactly what's triggering or not, but even though the code will execute, you'll get a notification from Defender saying like the file is malicious and asking if it can send a report to the cloud to check and see if it's a virus or not. Yeah, it hasn't been updated recently, but I used it. I haven't used it in like the last 6 months, but I was using it last year fairly consistently. It is kind of a pain to get set up because of some of the stuff that's going on, some of the changes that are. Yeah, it should, but it is a little bit of a pain to get set up because of the way Defender's doing some of this stuff now. So now we'll go to the final sample, which, like I said, was a default Empire payload from Empire 2.5 before we forked it. I have older definitions, so again, you guys might have to do some different things than I have to do to get to run. Oh, just another note for when you're doing this kind of obfuscation stuff, is that Defender or /AMSI kind of keeps a running tally on your current risk level of the computer. So if you're testing a bunch of this stuff, you can cause it to just start flagging on everything, because it just has decided that you've triggered it so many times that like PowerShell is basically malicious in and of itself. If you can either sometimes restarting the computer or the VM will reset that counter. More recently, it looks to be like a time-based thing, so just waiting like an hour or so, and then your script will start working again, potentially. But like that is something that happens, is it'll start, your risk level will get raised too high, and then everything just starts getting flagged by default, and at that point you just kind of have to wait for the risk level to get reset. So running this sample, we get flagged. The first one is this AMSI bypass down here, where we have this system.management.automation.AMSI utils is being flagged because of the AMSI utils definition. So we do some concatenation there. Same with this AMSI init failed. Christian, I have not found a good way of seeing that counter. I've done the PS AMSI kind of ties into it a little bit to figure that stuff out, but I have not found a way to dump like your current risk level. So we go ahead and do that to go ahead and get rid of our AMSI keywords that are flagging there. Another part of this is the actual order of the code is getting flagged. So if we go ahead and just move some of these functions that are order independent, like the $sir and the $t are order independent because they're just a variable getting set, so we can kind of set them anywhere as before they're used to move them around. And so that'll fix it. The old Empire project actually had this issue here, where it was repeating this command twice in a row. It was a bug in the code, and that was actually one of the key indicators that Defender was using to detect Empire. So removing that is necessary. And then we'll see with my current definitions, this should run now. Yeah, so that successfully ran. If you have updated definitions like I have on my other VM, there's some other things that have to be changed. Specifically, it is now, let me open it real quick. And I will go full screen to make this easier to see. Specifically now, it's if you look at the sample, there's this if PowerShell version major. This if statement in conjunction with the script block logging stuff that's being done is flagging. And so if you remove the version check, that is the final thing that is necessary to get this running in past Defender. That version check is, I've tried changing it to a couple of different ways of calling that version check, but it seems that the signature now is any kind of version check in conjunction with accessing the script block logging stuff is being flagged as malicious. The version check only really matters if you expect that you might be encountering PowerShell 2, which is not really common anymore in engagement. So we're gonna, part of the update that'll be pushed out to Empire for the tomorrow is that that version check will be an optional condition instead of being just in there by default, because most engagements aren't going to have to worry about dealing with PowerShell 2 anymore. Yeah, Nicholas, that's correct. It's a lot of trial and error. PS AMSI can help narrow it down, but a lot of times nowadays you'll just, even using PS AMSI, you'll just get your whole script block returned back to you as being malicious rather than like a specific piece. So just to go over this real quick for the third one, one more time since it was asked, removing the version check, the if statement that's this if PS version major, just removing that if statement because it's just making sure that we're running in PowerShell 3 or greater, which is pretty much almost guaranteed at this point nowadays. Going through and changing our AMSI bypass here, just doing some concatenation on the keywords of the AMSI utils and the AMSI init failed. And then reordering some of the variables. Like I moved this server, the $sir and $t up to line 23 and 24, whereas in the sample before they were down on 31 and 32 to break up the order of the code. And then there was this repeat of the headers that was in there, and you delete that repeat. Hayden, I'm not familiar with the ISE steroids. I have not used that project. So that's how you get all these scripts obfuscated and running. So now, Coin, if you want to go ahead and so we'll go ahead and move on. So invoke obfuscation. I'm gonna go ahead and demonstrate this for you guys. It's more just to demonstrate how it works, so that you understand the options that are available inside of Empire, because Empire doesn't have the interface for invoke obfuscation. It just has where you can set the options you want to use. So it's more just to familiar guys with how it works. It's also a really useful tool. Using this, even without making the changes I did by hand, you can still obfuscate away like the default Empire payload so that it doesn't trigger either AMSI or the secondary trigger I talked about where it makes a request to go double check that it's a virus. You can, using invoke obfuscation, you can still obfuscate that code enough to bypass both those things. So with some updates to Defender, you actually can't run invoke obfuscation on a Windows machine without having Defender completely disabled. So now we're actually just using it in Kali because Kali runs PowerShell Core 7, which makes it easier to get set up and have everything running. But we'll go ahead and walk through just some of this stuff. I'll walk through the slides real quick, and then I'll do some demo for you guys. So this is just like a quick tutorial. If you type tutorial once you get it running, it'll give you some useful information on how to use it. It'll tell you like the various how to navigate through the menus, how to test things, and all that kind of stuff. It's just a really quick overview that's useful if you get stuck. The example code we're going to use is sample 4, which is the same as sample 3. It's just it's not broken up into lines. It's just left as a one-liner. So I will. So token layer obfuscation is kind of the primary thing that we use. Really, I don't use much outside of the token obfuscation and the AST obfuscation anymore. But the token variable will change the variable names like I kind of showed by hand, so that's a really useful one to use. Token all will run through all of a bunch of different options, but it's only the order that it runs the token obfuscation things in is only pseudo-random. And this has been out long enough that for the most part, if you just run token all, your payload's still going to be caught. It won't obfuscate it enough or in a unique enough way for it to be bypassed. And then the last thing that we typically run is white space 2 to 3 times. Secure, you can do that. The issue is it becomes really tricky to try and build your obfuscated code and test it on the same machine without getting invoke obfuscation schwacked when you turn it back on, which is why it becomes difficult. So it's more matter of convenience for like being able to test the code versus more than anything else. Like, not that you can't do it. So the abstract syntax tree is like a key way that's kind of breaking up the structure of the code, and is one of the ways that AMSI works, looks through things. This is actually how PS AMSI is evaluating things, is through your abstract syntax tree. To be honest, I'm not super familiar with exactly how abstract syntax trees work, or at least well enough to teach it. It's kind of a interesting way of just linking structures of code to identify like code that is all interrelated. So encoding is another useful one. This is more useful for getting past things like mailboxes and that kind of stuff that are scanning for static code, because encoding for the most part will be removed before AMSI evaluates it. And it also causes your stuff to grow pretty significantly, the size of your code. String is another one that you can run. It just says concatenation and reorder and reverse. Compress can be used in conjunction with encoding to get your size down and reduce your bloat factor. And then launcher is just, it gives you options for adding launchers onto the code. We don't really use this because Empire handles it for you. So like Empire 2.5 had an issue like where when you turn on obfuscation, your payloads wouldn't work because it was tacking on a launcher in addition to Empire also tacking on a launcher, which caused issues. So like just mix up your order of operations because it impacts how things are obfuscated. So like running token string and then 1-2 versus 2-1 will give you a different obfuscation versus white space 1, and then the order matters. So Coin, if you can go ahead and switch over to my screen, I'll just give a quick run through of it on my machine. So, like I said, this is a default Empire 2.5 payload. It's the same as sample 3, just kept in its one-liner form instead of as a broken out into lines. Yep. Cool. So now we've set our script block. What just happened? There we go. Just got it. So now we can do token. One of the downsides to running it in Kali is it won't let us do like token /string/1, so you have to go run it by hand. But just to show kind of how, yeah. Just to show you kind of how powerful it still is. Like I said, just running token all by itself won't obfuscate things away. But if you use that AST function, especially since we know the AST only works if you're going to be running in PowerShell 3 or higher. But like we said, it's fairly uncommon to run in PowerShell 2 nowadays unless you're purposely doing it. If you just run AST all, and then go back, and then back, and then run token all on it. Oh, that was an invalid. That was a typo. It'll obfuscate all of our stuff.
Did we lose Hubble? Yep. Can everybody hear me?
You might have to give him a second to reconnect.
Yep. I think he just needs to reconnect. It looks like this whole thing froze.
Okay, can you guys hear me again?
Yep, Hubble, we can hear you.
Okay, cool. So yeah, sorry about that. So yeah, so yeah, just running the AST all and token all is actually enough to get us where we should be able to. Oh God, what just happened? No, I'm having some issues. Sorry, guys. Oh, crap. Okay, well, we're not gonna. My VM's not cooperating, so we'll move on. But the AST token all is for the most part able to get past a lot of things. Yeah, Twitch is probably a good idea. Token, just AST all and then token all. But something just happened to my VM. I'm not sure what I did. Okay. So I have to restart invoke obfuscation. But anyway, that's usually enough to get it past Defender. So we can try real quick one more time. So AST all and then 1. Cool. Yeah. So now we'll go ahead and attempt to run this just to see if it works. So now we run it with all the obfuscation. Oh, didn't work that time. So we must have gotten some new signatures pushed. But so you add in a little bit of stuff by hand. I did one earlier, add in some stuff by hand, but that AST and token all one's a pretty powerful one. So we'll go ahead and move on though from there. If you could switch the slides back. So you have access to invoke obfuscation inside of Empire, where you could see on the slide in that red box. If you turn obfuscate on or set it to true, that will start running invoke obfuscation, and then the obfuscate command is what options will be ran. If you just comma separate the options you want, then it'll be able to run multiple options. So do like what we just did. You could do AST all /1 comma, and I'm dropping this into the chat for you guys. Like that, and it'll run both options for you inside of Empire. So now we're going to get into our AMSI bypasses. So we just went through all this effort talking about how to obfuscate code to get it past AMSI without the need for a bypass specifically. So what do we really need this for? And the reason is that all of this effort only gets our first stage obfuscated. So as soon as the next stage is loaded for our payloads, or the third stage where we load a module that's malicious or something like that, it'll become flagged. So the AMSI bypass is to make it so that we don't have to obfuscate the rest of our code once it's in. Once we've gotten our first stage executed. So that's why we still need it, because obfuscation is time consuming and causes lots of bloat and just makes life harder than if we just disable the detection in the first place. So this is getting into where what we're talking about, how AMSI builds up risk profiles. Is if you dump the AMSI logs, which I believe the PS AMSI will give you the returns for the logs as well. It's been a while since I used it. But the various results it'll turn in the scan results section is either a 0, a 1, the 16384, the 2479, or is 32768. I've never seen it return anything more than that, or anything different than one of those options. But technically, how AMSI is evaluating is that number is actually a running total based on what it sees in your code, and so anything with a risk value higher than this 32768 is considered as is malware detected, and it flags it and kills the process. So that's what we're trying to do, is be under this 32768 rating. Unfortunately, I have been unable to find a way to get your actual total value rather than just a either one of these 5 options returned. Just a note, the difference between the AMSI result clean and the AMSI result not detected is that a not detected means that while it doesn't believe it's malicious right now, it could be malicious in the future, whereas the result clean says that basically the code is not malicious and couldn't be malicious in the future. I don't think I've ever actually seen a 0 returned as a result. It's always been a 1 or the 32768, unless you have like a policy block, which is these the admin start and admin end things are just policy blocks. So just kind of getting into this probably doesn't work anymore. This was from back in our class. Just another reason as to why we went through all this obfuscation stuff is to go over the fact that, like, this was an example I saw online from someone's blog of they were trying to use like a traditional TCP client that gets flagged as malicious, and they went through back when we ran this class back at DEF CON, all you needed to get this code to run and not be flagged as malicious anymore was use a .NET call to the TCP client instead of like the new object, and it was no longer flagged as malicious. Whereas because the author of that blog didn't really understand why, like what was causing AMSI to flag on it or how AMSI worked well, they came up with this super complicated, convoluted obfuscation to get it past AMSI, because that was the only way they were able to do it. Whereas if you can identify what is causing your flag and what the issue is, it becomes much easier to obfuscate your code and get like your bypasses working and that kind of stuff. So Rafe, that sometimes you will get it adds in like some arrays and stuff that don't get called quite properly, and it'll throw errors, but the code will still execute. It'll throw a couple of syntax errors, and but the code will still execute. Like you'll still get a callback. It's kind of weird. I haven't been able to figure out what inside invoke obfuscation is the reason that happens sometimes, but it hasn't really caused us any issues so far on our engagements. But getting back to the bypasses, the simplest bypass that still works is the one that's published by Matt Graber all the way back in May 2016, of this reflective bypass that goes in and disables the scan, the initialization field. Yeah, Rafe, did you hear me? I don't think he heard me. Okay, I'll let Coin handle that. So this still works. This is what the bypass that we were obfuscating in in the code samples. And when I say it still works, it works for PowerShell. It actually, this bypass won't disable AMSI fully. AMSI will still work in the common runtime language context, so it only disables it in the PowerShell context, which, depending on what you're doing, sometimes when you load assemblies, you'll have AMSI flag it because of the CRL environment and not because of the PowerShell environment. But we haven't really had much issues using this bypass in conjunction with Empire still. It's just something to note, especially if you use a lot of C# and that kind of stuff in your engagements. So what it's doing is, if you go find the AMSI DLL, when you look at the source code for it, or use a decompiler, there's this field that's AMSI init field, like this AMSI initialization, and it turns out that when they developed it or whatever, the developers decided that if for some reason there was an error when AMSI was loaded, that it would be better to just default to returning a scan result not found, or scan result not detected. Oh, it's a typo in our code. AMSI result not detected, rather than breaking like the use of PowerShell or whatever AMSI scanning if there was an error in AMSI. So if we just set that, we tell AMSI that it had an error while it was starting up, we automatically get a no result detected answer back from AMSI without it ever scanning our code in the first place. So, and like I said, this works because when it's going to do the security check, even before the content is scanned, it's saying that it already failed in its initialization, so it just returns an answer result not found. You never get to that scan content step, which is that fourth block down, if you guys can read it. And the reason we're able to do this is because the AMSI DLL is loaded as part of your PowerShell process context. So the AMSI DLL is running at the same permission as PowerShell, which means that PowerShell has permissions to modify the memory space of AMSI, which enables pretty much all of these bypasses. Is that the AMSI DLL is loaded into the context of your process and is not a separate process in and of itself. So you have authority to manipulate that memory space. So bypass 2 is a more complete bypass. It should impact the common runtime language environment as well as the PowerShell environment, but it is a more complicated AMSI bypass. This is similar to the Rastamouse bypass in Empire. You'll see it attributed to Tal Lieberman because I wrote the code based off of his presentation from that he gave at Black Hat. He had some example codes in there, and I based my stuff off of it. But it's essentially the same functionality as the Rastamouse one. This was just a little more compact. It's about 20 or 10 to 15 lines of code shorter than the Rastamouse one, so we modified it and put it in there. And at the time, I based it all off of the Tal Lieberman one. Yes, so the Matt Graber is the AMSI bypass 1 option, and the AMSI bypass 2 option is this one that I wrote that we put in there. So the first part is using C# to export some of the functions from kernel 32 that allows us to identify the memory space that AMSI DLL has been loaded into. And so we just use those to then get the member definition and all that kind of stuff, and get our handle, and then use virtual protect. It's very similar to the sample 3 that we were obfuscating as well. So this exports some functions for us. Then we modify the memory permissions to ensure that we have access to it, which is what this next section is doing. And then we modify the return function memory space to always return a value of result not detected. So this is different than the previous one because our code is actually being scanned. So it's a little less suspicious to Defender. So our code is actually being scanned, but it just always returns a result of no issue found or no result detected instead of not scanning it in the first place, which is why it's a little more powerful, even though a little more complicated. And this bypass we've seen, so I actually also took some of the code base from in a code sample that I found of Turla, which is a Russian APT. They use this bypass to sorry, I just lost my train of thought. This is actually a bypass that has been used by APTs in the wild, so it's one of the reasons also why I modified it to be in there. So yeah, as we talked about, you can use these AMSI bypasses in conjunction with your obfuscation, and everything works well. Oh, that's a good caveat track. Thanks. Yes, you only want to run one because the both would be overkill. So now you can re-enable Defender and try running your Empire launcher with the bypasses enabled and using invoke obfuscation, and you should be able to successfully get a callback. We'll give you guys a minute to test all of that, and I'm going to drop off for a section because I need to grab a glass of water. So, Coin, if you can handle the questions while I step out for a second.
Sure thing.
Okay, I'm back.
Well, we got a question, and I'm really going to direct it to you. I don't know if you know the answer about the unloading AMSI DLL.
I don't know if I've just mostly used these bypasses. I haven't tried unloading the AMSI DLL itself to see what happens. Especially with the modifications to Defender, I would assume that you'd probably get flagged as malicious just unloading it directly. But I would have to look into it some more. I haven't tried that specifically. Yes, you can. Joseph, you can use a comma to obfuscate most of that. Okay, so now we're going to get into our sandbox detection and evasion. And we'll see how that goes. So just a quick overview for anyone that's not aware, a sandbox is just a software created environment that isolates and limits the rights and accesses of a process being executed. It's an effective way of doing behavioral analysis instead of just relying on static code analysis. So you can run code samples and look for behaviors instead of trying to identify exactly how the behavior is written. And they're becoming much more prevalent in all kinds of stuff. You know, Windows now has a sandbox built in. And coming out soon has been announced that they're going to start running all like Office products in a sandbox, so that like malicious macros and stuff like that will have a much harder time because they'll be sandboxed, hopefully not able to escape that. But they're just becoming a very prevalent way of doing antivirus detection and that kind of stuff in malware analysis. So Gmail now has sandboxes, Outlook's using sandboxes, and lots of stuff are just effectively using them now. So basically, like I said, sandboxes are used because you would need almost an infinite number of signatures. Sorry, got a message from Coin and got distracted. Like you'd basically have to have an infinite number of signatures to account for code obfuscation, that kind of stuff. So it becomes what we call heuristic-based analysis, and it's super powerful. So instead of trying to obfuscate our code or whatever, we try to identify that we're inside a sandbox and just choose not to do something malicious when we detect that we're inside a sandbox instead of on a computer. So what are some of those ways that we can detect that we are inside a sandbox? The three key things about it are that'll kind of really work in our favor for identifying sandboxes is that they, especially in the context of things like Outlook or Mailbox sandboxes that are scanning for malicious attachments and that kind of stuff, is that they are limited by their time, money, and resources. Time, like, is users don't want to wait 3 hours to be able to get an email. They want, when they send an email, to get it almost instantaneously. Where money is that they have to be able to, money and resources are related, but money is they have to be able to afford all of the hardware and software and everything that's being run in order to analyze this code. And then resources, we broke it out because it's tied more to the just sheer volume of things that they're trying to analyze. There's thousands, tens of thousands, hundreds of thousands of emails being sent every day, probably millions of emails being sent every day through Outlook. And so they have to constrain the resources that are used for each attachment that's being scanned, or they would quickly run out of money. and not be able to afford that, and it would just bog everything down. So we can use that to start trying to identify limitations of the sandboxes we're in, and look for that causes abnormal behavior from a sandbox compared to a bare metal. So we'll go over a couple of different things. First, the simplest one will be password protection. Then we'll talk about some time delays, specifically in the context of like malicious macros. We'll talk about auto open versus close. Check for limited resources, and then look for kind of virtualization processes. So this is a quick thing of just walking through how to embed a macro using Empire. The stager that we can use for that is Windows macro. So the new Defender updates for the for signatures are going to make it really hard for the macro to be obfuscated. The Defender without, it's not, you need to use a different launcher that's built into Empire by default, which we'll push out later. And actually, I'll show you guys when we're done walking through this that for some reason Defender is actually allowing one of the oldest ways of launching PowerShell from macros to start working again. It used to be flagged, but it's not right now. While it's gotten really hard to obfuscate some of the more recent macro launchers, which is kind of interesting. So in Empire, you just use the use stager Windows macro, and then set your listener, and you can press execute. Jesse, were you able to run invoke obfuscation? It sounds like you might not have, or well, no, it looks like that might be a PowerShell issue, like an issue with your PowerShell on your Kali box. That's what it sounds like. Otherwise, I'm not sure what that error would be. So if you just have to set the listener to test and then execute. It'll in the window. It'll give you a macro that you can cut and paste over to into Windows into the macro, and then right now that will be flagged when you try to save it as malware and potentially deleted. But to turn on the developer options to get to your macros, you're just going to go to info, customize ribbons, and then developer. I'll leave this up for a second for people to use it. If you're on the dev branch, so the dev branch has all of our updates, so none of your stuff will get caught. If you're trying to obfuscate, this stuff should be all bypassing the signatures by default now, but so that should enable all of your macro or your developer window. Then you can go to developer and click on macros to open your macro editor. If you don't have any macros done, you'll have to give it a name for the macros, and then just click create. Then you can just drop in your macro there, and then like I said, if you're on the version on our current version, not the dev branch, it'll be flagged when we try to save it. Yeah. So yeah, and then you can just move it over to your proper file or to your proper Word document from the normal template. So then we'll get into our evasion techniques. So we want to do all of our checking for the malicious or for our sandboxes before we do anything that could potentially be malicious. We do have to be careful because some of the checks in and of themselves can be considered malicious. depending on how prevalent they've become. So we don't want to start a new process or reach out to the internet or anything like that before we do our sandbox checks. And sandbox evasion is becoming more and more prevalent by more sandbox evasion is becoming more and more prevalent just by APTs and like in the wild. So it's something that's becoming seen quite often nowadays. So the easiest one when we're using like an Office document or something like that is to just simply password protect your document, because the sandbox doesn't have a way of knowing what your password is. So it can't open the document to see if anything malicious would be done, so it just passes through the sandbox. The issue with this in the context of like an engagement or whatever is then you have to come up with some reason for the file to be password protected to the people that you're sending like your phishing emails and stuff like that. And just the fact that it's password protected usually ends up with a lower success rate. But you can send like the password in the email and say that they need to enter it for security or something like that. So it is something you can use. So another one is a time delay, as we talked about. People don't want to wait for their emails, like, for hours, that kind of stuff. So typically sandboxes stuff only delay the attachment for a few minutes at a time. This doesn't work as well in the context of a malicious macro, simply because like if you put in a time wait, you tell it to wait like 10 minutes or something like that, the user will be unable to close the Word document, and it's kind of a big flag that something's wrong. Like they might restart the computer or something like that. So like this one is not as useful for malicious macros, but it is something you can use. And so just something to keep in mind. The one that's most commonly used nowadays is checking for resources on the bare metal. So like a really common one is that like checking for the existence of a fan. Quite often sandboxes won't say that they have a fan, or virtualized environments there will be no fan attached to the defined in the WIMI objects. The only problem with using WIMI objects is that they are super inconsistently implemented by manufacturers. It was supposed to be a common implementation that everyone kind of followed a standard, but there were really no standards ever published. And so it's entirely possible that you do this check and it doesn't say it has a fan, but you're on a real computer. Or another one is like checking for screens, like on laptops. Usually, if it's a laptop, it'll have a screen defined in the WIMI object, but not necessarily all the time. So it's best to do like a couple of these checks to try and figure out where you are. So some of the useful WIMI objects to use for doing your checks is this Win32 computer system, Win32 logical disk, fan and video controller. And then just on the slides, I have the command both in PowerShell and then how you do it in VBA to check for it. So there's that. Checking for processes is another really useful one, because most, if not all, sandboxes result in addition of management processes. So you can look for like that SBIE service or SBIE control is sandboxy. VM tools is VMware, and VBox is VirtualBox. But there's lots of ways to look for things like that if you know what process you're looking for. I'm not as much of a fan of looking for the processes one, just because it usually ends up, like if you go look for some of the APT samples and stuff, you end up with just like a laundry list of like 30 or 40 processes that you're looking for. and it becomes tedious and I think there's more effective ways to look for stuff. But if you want to, like, it is an effective way if you're trying to, especially if you're trying to do like anti-analysis stuff. So like I said, there's no one guaranteed way to work for this. So it's really useful to, if you can do reconnaissance on your target environment to figure out, do vishing and figure out what model of computers or like what manufacturer of computers they have, because like for the most part, Dells will all have the same WIMI objects defined. Use multiple halting conditions. And then I like to use the MITRE attack framework stuff, because when we do engagements, we do our best to emulate APT stuff, because we'd rather produce assessments based on stuff that they're likely to see rather than just stuff we know will get past their things. So here's just kind of a thing that we went through for Evasion development last year. We were doing an assessment and we're testing a payload, and I sent it we knew that our target company was using Outlook, so Coin had an Outlook account set up, and I sent a payload to him to see if it would get past the scanning, or like the AV scanning on Outlook. And instead of it not going through, well, it didn't go through, but we also randomly got a callback from the mail server that we weren't expecting. And so at first we panicked and thought maybe we'd accidentally sent it to the wrong person, and it had and they had opened it, but we tested it a few more times, and it turned out that it was Outlook had implemented their APT sandbox or ATP sandbox features on all Outlook accounts, regardless of whether or not you're paying for ATP. And it was allowing for callbacks back to our C2 server. So it would cut off after, the 5-minute evaluation period or whatever, but it did allow us to send information back. And we were able to pull like the serial number and the number of cores and like the disk size from the sandbox. And it turned out that like the serial number was always the same regardless of the sandbox, or regardless of how many times we sent like our payload through the sandbox. It would always detonate and have the same serial number, the same number of cores, and the exact same disk size. And so we were able to do that to build like a tailored Outlook evasion. As far as we could tell, these characteristics are still the same on Outlook's sandboxes. We tested it earlier this week, and our attachment still went through. So I don't know if it was that our signatures didn't cause it to weren't suspicious enough to cause it to detonate, or if it was just our the criteria is still the same. Just it sounds like your threat profile might just be too high at this point. You might have to start like so rebooting typically works, but this week I have not had success with rebooting, resetting it. Yeah, so you might have to. Yeah, unfortunately, I had to just wait for it earlier this week when I was testing stuff. So now, if you guys have like an Outlook account you want to try sending stuff to, you can put it all together, and basically we'll just spend the next few minutes to do, or however long you guys want to stay on, we can do a Q&A for you guys, and thanks to everyone for coming. That's kind of all the information we have for you guys.
Hubble, we had a question about the alternative use or alternatives to IEX. Do you happen to have anything that you could talk about for that? I know you were doing some obfuscation this week, so maybe if you wanted to show any of that stuff off.
I have not found a good replacement for IEX yet. That's kind of the Achilles heel for doing C2 through PowerShell, because you have to send everything as strings. So trying to convert it, figure out a way to execute from strings is proving to be a pretty good challenge. Aubrey, from as far as we can tell, none, because it's external to their perimeter. So they're they're scanning for all kinds of spam and all that kind of stuff. So detonating in the Outlook Sandbox environment doesn't really have any impact on the customer. Well, yeah, that's a good one too, Joseph. We have not got a ton of experience against EDRs tracked. We've been trying to figure out how to get some access to them, but we actually will probably we're hoping to be giving a talk some more about this at some of the conferences when they come back on. We're seeing a trend. We're still seeing a trend of clients not using EDR. They're relying on some of the next gen network defense stuff. So like we did an assessment against a company that was running like Darktrace. It's like the new Super Gucci AI enabled IDS stuff, but they were still just using Defender as their endpoint detection. Because I mean, honestly, Defender is pretty good for the most part, but we're still seeing that as because Defender has become such a useful endpoint protection product. We're seeing less of the EDR solutions than we have. Yeah, we're aware of it. That's what we're saying. We're seeing a trend of clients paying up for network defense stuff, or for like network traffic analysis and IDS stuff instead of an IPS instead of running endpoints. Ray, we mostly interface with small companies that haven't had their own SIEMs set up. We haven't done like a major assessment with like a a company that's got a full SIEM set up and everything. Yeah, we were very successful against Darktrace, even just running Empire with some modifications to the 2.5 branch. We didn't really start getting caught until we were purposely being loud just to try and see at the end of the assessment to see what things were going on. The slide deck's already on our DEF CON or on our GitHub page. I mean, I guess it kind of depends on context, Joseph. I honestly think that Defender is a really good product, and they continually make updates to it and are making it consistently better. The updates they pushed last week are pretty significant capability upgrades to it. But I do think there are still there's still ways it could be improved. I don't think it's the best EDR solution out there, but I do think just a traditional antivirus, there's no other reason to buy something that's not Defender. Yeah, I've seen that too, Joseph. Like that's one of the. It's interesting because some of the EDR stuff's really good, but then they disable the like one of the valuable things that would give them more insight to be even more effective. Yeah. Yeah, I agree, Ray. Defender is just one part of the whole puzzle, but yes, it does. Pravesh, I hope I pronounced your name right. It does. It does. Everything's in memory. We're looking into putting some stuff together. We've been fairly busy, so we want to take the opportunity to run this one. But yeah, we're working on putting together some other trainings.
Any more questions? Anybody has? So Joseph, that's actually one of the things that we see that kind of sets like some of the low tier people that emulate adversaries compared to what we do is running things in the lab environment, testing all our payloads, and really setting it up as close to reality for what we think they're running as possible.
Yeah, so Joseph, sometimes something I've done in the past is infect a single computer and then try and pull the GPOs so that we can get information on that, and then use those GPOs to set up our lab environment so that we basically have a replica of the network set up so that we can test our stuff before we're doing it on network.
Yeah, and then just to pile onto that, that was one of the big things that why our attack with Outlook and the Sandbox was so successful, is because we ran a lot of tests before we actually employed it. Joseph, you're asking about how much time we plan for like assessments. Typically 2 months is usually what we aim for. And that all depends on if we're doing a white box or a black box test. Documentation really could be key if it's a product we're not too familiar with.
Yeah, it depends on. Well, so the actual execution won't be like 2 months. It's more that's how long we plan for doing like research and that kind of stuff. But the GPO thing is more of a thing I've done for some longer term engagements, like the week engagements and stuff. It's a little harder to do. But I've done some longer term engagements where that was something we could do because they were really more interested in persistent threat replication than just kind of coming in and like smashing the network. Yeah.
And we do a lot of stuff for like non-traditional systems, so a lot of embedded devices, Bluetooth devices, just more of your not traditional systems. So it requires a lot more research on our part.
So lessons learned secure. So this is one of the things that again I kind of think that I learned when I was on the Air Force Red Team and stuff is you should never be, as much as you possibly can, you should never be typing commands during an assessment. You should have what you're planning on doing already built out and just cutting and pasting your commands in. So that way you don't accidentally, set your beacon to sleep 0, and now you're just lighting up the whole network and everything gets quit. One thing I did do during an assessment that was a lesson learned was when you're messing with routers, make sure that you're paying attention to which direction you're applying the ACLs to, because I've definitely locked myself out of a network by accident before by placing firewall rules that were meant to prevent the defenders from accessing it, and instead of locking myself out. But the biggest thing too, I would say, is just open communication with your customers. Like, make sure that they have an understanding of what they're asking for, and an understanding of what your capabilities are. Because a lot of them just don't understand what exactly that they know that they need to do a pen test, or they need to do a a red team assessment or whatever, but they don't really know what that means. So we like to sit down and make sure that we have a good understanding of what their goals are for the assessment, not just that they want a pen test or a red team coming in. So I would say, like, the biggest thing about red teaming is really just research, of having a good understanding of what you're trying to replicate and what the goals are for the customer. They're a pen test is trying to identify the distinction we kind of make for it is pen testing is really testing technical controls, like, do they have the right permissions set in their environment? Do they have firewalls, in places, that kind of stuff, where red teaming is testing their processes of, like, when they get a detection, are they responding to it? Are they, following up on alerts, that kind of stuff. Thanks a lot, guys. I appreciate everyone coming out and sticking around. Feel free to send us an email. I hang out in the Powershell Empire Slack channel that the Bloodhound Gang guys still have up, so you can contact me there. We also, any issues you have, just open an issue on GitHub, and we're pretty quick to respond to those too.
All right, and we learned that we can't unload AMSI.dll, so that's good. So
that's what I thought. I didn't want to commit to it though without going and check.
Yeah, we'll have to dig into that one a little bit more. Yeah. I posted a link to the Bloodhound Gang, so if anybody wants to jump on that Slack, I know I'll hang out there a lot. Otherwise, I appreciate everybody sticking through, and hopefully everybody learned a lot. Once again, I'll put in our email again. If anybody wants to send recommendations or feedback, it's greatly appreciated. That way we know what we can improve in the future. Obviously not using Webinar Ninja. That's probably the biggest improvement. So thanks, guys. I appreciate it. So we're going to be jumping off. Or use Twitch. Thanks.